Okay, so this is multiplying and dividing numbers in scientific notation. So here we have two numbers written in scientific notation, right? A number between 1 and 10 times a power of 10. That's scientific notation. We can see we're multiplying two of those numbers. So we'll do a few examples of this. So the way that we do this multiplication is, this is multiplication here and here and here. So it's all multiplication connecting all of these terms. So we'll just use commutative property and reorder them so that the powers are multiplied by the powers and the decimals are multiplied by the decimals. And then we just do this multiplication. So I'll come over here and do this work. So I'll do 4.17 times 1.2. Let's do decimal multiplication. Down to 0, 1 times 7, 1 times 1, 1 times 4. And then we add those up. Move the decimal a total of 3 places over. So we have 5.004. So that's the first number in our scientific notation. And then we have to do the powers multiplication. We have to do this 10 to the 4 times 10 to the 7. So if we remember how to multiply powers, we know that when you multiply powers with the same base, you add the exponents. So we'll just add the exponents. And then we'll bring that 10 to the 11th power. And we can see that once we've multiplied those, we have an answer that's in scientific notation. Make sure you check. Sometimes when you multiply these two numbers, the 4.7 and the 1.2, the two first numbers of the scientific notation, you end up with a product that is larger than 10, so it doesn't follow the definition of scientific notation anymore. You have to adjust it. But in this case, 5.004 is between 1 and 10, so this is in scientific notation. And that's a basic example of multiplying two numbers in scientific notation. So let's look at one more example. And in this example, we'll see that we have to adjust that first number. So again, we have two numbers in scientific notation. We're multiplying them together. So we'll multiply the 9.01 times the 9.7. And we'll multiply the 10 to the negative 4th power times the 10 to the negative 4th power. So first, this multiplication. So let's go over here. I'm going to put the 9.01 second. 1 times 7 is 7. 1 times 9 is 9. Bring down this 0. That would just be 0 times everything. So then we'll bring down another 0. 9 times 7 is 63. 9 times 9, 81. Plus 6 is 87. We add all that up. 1, 2, 3 decimal places. So we can see that we got an answer of 87. I'm going to round this to 87.4. The whole point of scientific notation is writing a number that is, takes up less space on the page, so it doesn't make much sense to have all these digits here. So we'll round to the nearest tenth. Then we'll do the powers multiplication. So we have 10 to the negative 4 times 10 to the negative 4. Now remember the rule for multiplying powers is add the exponents. So we have 10, we have negative 4 plus negative 4. So these are same sign, so we're going to add them. So 4 plus 4 is 8, and they're both negative, so it would be negative 8. So we have 10 to the negative 8. So now we did the multiplication. So we have 87.4 times 10 to the negative 8, and we can see that 87.4 is not between 1 and 10, so this is not, our answer ends up not being in scientific notation. So we have to adjust it. So we're going to move this decimal over 1 to make 8.74. Now, clearly we can't just move this decimal. This 87 doesn't have the same value as 8.7, so we have to adjust this exponent. So it's like I took a times 10 out of here, right? 87 became 8.7. And moved that times 10 over here. So there's like another 10 over here. So I'm going to add 1 to this exponent. So if I make this side one decimal move smaller, I add 1 to this exponent. Now be careful when you're adding that. -8 plus 1, right? These are different signs subtract, so don't make it -9, right? If we add a positive 1 to -8, it would become -7. So I made this one decimal move smaller. I make this one exponent greater. -8 plus 1 is -7. And so let me make that negative a little better. And so that would be our answer in scientific notation. Same value as this, but in scientific notation with this number between 1 and 10. So this happens sometimes when you're doing operations with scientific notation. The number you end up with here is not between 1 and 10, and you have to adjust. So those two examples of multiplying numbers in scientific notation. So let's do divide now. Dividing numbers in scientific notation. So here we can see, let me move that over a little bit, two numbers in scientific notation, and they're being divided. So the way we do this, very similar, is we just, we divide the decimals and we divide the powers using the appropriate rules for each. So let me divide 8.7, kind of split it into two parts. So I'm going to divide 8.7 divided by, sorry, let me move that down a little bit, divided by 2.7. If we remember about dividing decimals, we have to move, we can't have a decimal in our divisor here, so we're going to move that over, making it 27, and this 87. Actually, I'll just rewrite it here. So move those decimals over. So then we're doing 27 into 87. And I'll go ahead and put a couple zeros here. So 27 goes into 87 3 times. 3 times 27 is 81. Subtract, we get 6. Bring down that 0, 60. Bring up this decimal here. So 27 goes into 60 twice. That's 54. Now notice here we had a 6 and brought down a 0. Here we have a 6. If we bring down this 0, we're going to keep doing the same thing. So this 2 is going to repeat. So I'm just going to stop there. So that's the first half of our answer, 3.2 times. We're going to have 10 to some power. So then let's do the work of dividing powers. So now we have 10 to the 2. So now I'm just doing this calculation, the dividing powers. 10 to the 2 divided by 10 to the 6. Now, dividing powers is subtract the exponents. Same base, you subtract the exponents. So I'm going to have 10, and I have to write exactly as it is. So 2 subtract 6. So now I look at this. These are different signs. So we subtract them, and we'll use the sign of the number with the greatest absolute value. So 6 minus 2 is 4, but this -6 has more absolute value, so we'll have 10 to the -4. So then we just bring that over as part of our scientific notation. Now, again, we want to check that through our calculation we didn't end up with a number smaller or larger than 10, larger than 10, smaller than 1. And we didn't. 3.2 is fine. So this is our answers in scientific notation. We're good. So that's dividing powers in scientific notation. So let's check out one more example. And again, feel free to pause the video at any time, right, or rewind and watch something again. So here, same situation, two numbers, scientific notation, dividing them. So again, we want to just divide the decimals, do decimal division, and then do powers division. So I have 4.5 divided by 3.2. Can't have a decimal in my divisor, so I'm going to move that over. So then I'll rewrite that down here. Put a couple decimal places there. That decimal is going to come straight up. Might as well just do it now. So 32 into 45 goes one time. Bring down the 0. 32 into 130 goes 4 times. 4 times 2 is 8. 4 times 3 is 12. If we bring down this is 20, we'd put a 0 and keep going. So let's just stop at 0.4. Usually with scientific notation, one place or two places is good. So that's our first half, right? 1.4, and it's going to be times 10 to the something power, some exponent. So let's do this division. Now watch carefully. I put this example in here to illustrate a point that some people make a mistake on. So here we have 10 to the 3 divided by 10 to the -4. Now, dividing powers, same base, subtract these numbers. but do this, it's exactly 3 minus -4. You have to use exactly what's there. So the minus, the exponents is for the dividing, and this exponent is -4, so don't just put -4. It's minus -4. And as we all know, subtracting a negative is like adding, so it becomes 3 plus 4, just like any other subtraction problem that you might do. So we get 10 to the 7. And again, if we'd have done the reciprocal of this, that would have been 10 to the 4 in the numerator, and we would have added 3 plus 4. So it's the same thing if you want to flip this up to the numerator, doing the reciprocal. And so then we have 10 to the 7. And again, notice, right, this is between 1 and 10 times the power of 10, so we're in scientific notation. So no problem with that answer. So we only had to change the one time we had to adjust it. So that was example 2. So that's multiplying and dividing numbers in scientific notation.